Check, check. Hey everyone, Lazy Ben. Okay. So, today, get rid of that. I'm working through a couple of bugs, particularly this one, which is a crash bug. This red bar means it crashes. We're getting through it now. So the task is make distance fields DDS files. Now I don't think, actually, after I'd written that, I was like, I don't think distance fields could be DDS files because they are 32-bit floating point files. And I don't think DDS can compress 32-bit floating point files. So this is probably just going to be make distance field files. Let's store meta info. Because right now the distance field files just store the raw binary. So let's just pull the game. All right. So right now, whoops, the distance fields are stored here in this random jumble of letters .light. This is the thing we need to change. It needs to be store in like the width and the height of the light and the format and stuff. So it needs to really be a proper image file. If we look at light, you see we store like width, height, format there, and then we store the actual data there. The problem with this is if a level loads this and then we rebuild lighting outside of the level using the sprite sheet editor, loaded levels don't know about it. So that's what we're going to solve, hopefully. All right, cool. Just close that for a sec. Close some of these windows that I have up. All right. So let's just build and just see where we are. So we'll just close all but this. And then if we just open up, so I've got this test room called light debug, and it's got two lights in it. And you can see this just stores this information here. It's like a duplicate of this, apart from the format. Really, what we need is just a path to a file that contains all of this. So we're going to do that. Once it's built. So if we go to sprite sheet editor, wherever we build the light here. So this is where we name the file. This isn't actually where we save the file. I think we save the file actually when we're actually saving out the light layer itself. That's where we load it. The raw texture reader. Where are we saving it? Oh, just here. So we're literally just writing binary out. So I actually think that is not what we want to do. So where do we launch into? Into here. This is just this little test level I have with 2 lights in it. Probably actually want to launch. Okay, it's kind of broke. Maybe it's broke. We'll just check again. Can grab hold of that light. I can't grab hold of this light though. For some reason. So we kind of want to probably load into here. See, this is wrong as well. This is in the light's in the wrong place. So you want to load into light.spritesheet. That's here. So spritesheets. Light.spritesheet. I'll actually load into there. Okay. Interestingly, we get a crash if we put in the wrong file name. I think that's all this is. So let's might actually just solve that for a second. Rooms, sprite sheets. So it should be levels, but the rooms shouldn't be there. So we have to just kind of fix this crash first. So this is an open. What happens if we do a new? So the thing is, like, new calls open as well. So the file, the path might not even exist here. So it deletes it and then opens it. So we might just have a little here. We might just have a little fine. Getting off topic there. Let's just leave it. It is a crash. So we need to actually solve that. We'll put that in the notes. Whoops. When opening a file, so game crashes when opening a file in the editor that doesn't exist. Opening a file. I'm going to put when debug opening. It obviously doesn't crash if you're opening it in the actual editor itself, but this is like a debug. I'm like bypassing a bunch of stuff here. And that is a crash. Okay. So when we generate the light now, what I actually want to do when we save it, try and just get it to a different image format rather than just this. So can we do image? Let's just do im.from memory. Read from memory, and this is just a raw image reader. Width, height, channel count. So this doesn't have anything to do. Pitch. Width, height, channel count. So we need to put the pitch in really. So this raw image reader doesn't actually have in the bits per pixel. Maybe we need to actually do that as well. This is somehow doing it here. I've done this for so long. Width, height, channel count, pitch. So can we do layer dot distance field dot width, layer dot distance field dot height 1, and the pitch is actually 4 times layer.distance field.width. And the pointer is layer.distance field.buffer. Get data. Layer distance field buffer get size. And then what we want to do is we want to go im.write to file. Right. So if we do TGA image writer. I don't know if that actually it won't actually write F32. About the PNG one. Use the load PNG image writer. Does do bit depth. Okay. My problem, I think, with this is we don't actually set the bit depth, but we can see. We might have to rework this image reader to set a bit depth. Right now, I think the bit depth is going to be 4 bytes. No, the bit depth is right. The bit depth is 4 bytes. It's actually the format. The color type. See, that actually doesn't support 32 bits per pixel either. Does any image? What image format support 32 bits per pixel? Let's have a look. What image format supports 32-bit float? That's what I want. JPEG XL. Single channel 32-bit float. TIFF. libtiff. How big is this? Massive. Okay, does STB image write, or STB image, whatever it's called, image write support TIFF? No. 32-bit float. single header TIFF writer. Tiny TIFF. So reader, where's the writer? Data types uint 8 to 64 bits. So this would work, hopefully. Okay. So what I might do is not this. I might actually open just the general, because this is probably going to go in libbm this. And actually do make a TIFF image reader and writer. But first, what I want to do is get one of these distance fields. So we'll do the light one because that's most obvious. So we're going to copy this and put this into where we got the BM test. Put this into here. Got stuff to move there. Anyway, let's just try and load this file. Read binary. Get rid of that. What do we call it? So we're just going to call this test.light. Test.light. So let's just see if we actually can do that first. Okay, so we have it. So what we want is we need to know the size of this. So I think it was 306. Which was not this one. It was Alight. So that is 640 by 640. That, the width and height. So we're going to do image. Read from memory, raw image reader. So 640, 640. Channel count is 1. Pitch is actually 640 times 4. Now, I don't know. We actually have to pass in the buffer as well. Get size. Okay. So let's have a quick look and see what it has done to the format of this image. even if it is one at all. Pixel mode grayscale. I mean, kind of. It's not really. Pixel mode. So we've given it grayscale. What it actually is a 32-bit float. Got one channel of 8 bits. It says it's a grayscale. I mean, it kind of just can be implied, can't it? Anyway, let's just try. Let's just get this tiny TIFF. I just want it to be small. It's not really single header. It's header only. Tiny TIFF's fine. Okay. May as well put it in here. Result. This calls results. Okay. So let's do a new. Let's close this solution, and then we'll clone tiny TIFF, and we'll put it in. Here. Needs to be an empty folder. Tiny TIFF. Tiny TIFF. All right. Just want to build this, make a solution out of it. I even have CMake on here. I do have CMake. Okay, so we want to do is make dir build. And then we want to do CMake dot minus G Visual Studio 15 2017 64 dbuild shared libs so it's saying which doesn't work. Don't know enough about this. The source directory doesn't exist. So it's not. Oh man, I don't even know. Let's have a look at the make file. I do have 2022. I don't know if it's 15. Oh, that kind of worked. Did something. Build. Don't know what Visual Studio version we're on. $14 maybe. Debuild. It didn't actually make the solution. Uh, 17. So it looks like it says it's creating them. Don't know where it's making them. Oh, go. Could not create a name generator. Visual Studio. To specify architecture. Win64. Is it just X64? Yeah, this doesn't. This just doesn't work. Come on. Okay, let's not do build shared libs. Okay, that looks like it did something. Let's just delete that. There we go. God, this is a process. That was kind of harder than it needed to be. Let's hope this actually works. Wow, this is massive. It's meant to be light. it failed. It did build some stuff though. It built some solution. Let's see. Oh my god, look at the size of this thing. It's literally just to read and write one image format. It's called libtiny TIFF. That build does build though. Maybe this is not really the thing we need. Maybe we can actually build it ourselves. So much stuff though. I think I'm just going to try and build this ourselves, not actually from the solution. Okay. So let's make in third party tiny TIFF, and let's add a bunch of existing items. All those. Alright, let's just build and see what happens. Okay. Okay, so all these need the PCH. How do we do this with like, so the rest of them, so what do we do? How do we do this with here? That doesn't include the PCH file. How do I even do this? Does not participate in that debug. Got does not participate in build. So we must be including these somewhere else. PI common. So let's just quickly look where we include this. Include in the PCH.cpp. Ah, right. Okay. So all these basically just don't participate. And we have to include them all. So include tiny tiff. Well, that one. How many have we got? Only 3 of them. No such file or directory, it says. Directories. Because it's tiny tiff. Source. Invalid preprocessor command warning. Stopped it building. It is an error. It's just highlighted it yellow because it's got the word warning in it. Right, so this is clearly not built for Windows. Because this is not portable. How many times does this appear? Only here. That's annoying. So this kind of really needs to be Pragma message. How do we test? Have to edit this. let's try that then. I usually don't like editing libraries because then I can't change them. I upgrade them. God. There are warnings. Tiny TIFF export. So we need to actually unexpected token. Can it include tiny TIFF export? So there's more files. This is not very tiny. It's here. And here. So let's just copy them over to here. Hallelujah, it built. So it's inconsistent. There's a bunch of errors though. Well, bunch of warnings. Inconsistent DLL linkage. It's all in the, so it's a reader and the writer. Alright, before I continue with this, is there any other header only TIFF? Bunch of errors, bunch of warnings. So this is all got this inconsistent DLL linkage. It's probably going to be fine for me. So it doesn't, it's this export. Tiny TIFF export. Oh, I think we need to include them. Export. Version. Tools. We have tools. Defs. We have defs. let's just rebuild. And then let's see if this works. This actually works. So we're just going to do a right. Still got this inconsistent DLL linkage thing. But it does recognize this now. And that's probably because you've not put it there. Well, that's a bit weird. We may as well just fix all this. We want static define. I think. Okay, cool. I got rid of all them. So this is let's have a look at this error. It has built in. So this is going to have to get disabled. Are they all in the same? Well, they're all in internal, I think. Tiny div tools internal. Let's just see. Oops. So we need to disable C4067 from C tools internal. Can we just disable on a specific file? No. Okay, so there's only these three. We're going to say if MSVC there. An underscore. MSC there even. Define as built in 0. No, that didn't work. That possibly worked. So this is also so now we can return conversion from size T to unsigned long. This needs an actual cast. Oh, to the wrong thing there. The unsigned long. Here. It does has Aves read F. So we need to put that in there as well. include. Fine. I'm not convinced this is even going to work. There's a Windows thing there. Use Win API. If def use libc for TIFF reader, then it defines that. If not defined, then it just immediately defines it at the top. It's so strange, man. I think this is too much. This is just too much, man. Let's go back to the TIFF build one we had. Could just put in the library. Could just include the library rather than trying to build it. So would that mean deleting these and then deleting all this and adding existing items, which would be build output, those two. So no, it would be source these two. So that doesn't have any of the actual headers in it, unfortunately. Oops. Okay. Well, all I'm gonna do is just link to it. It's just such a shame. Then we've got to link it in as well with our executable. No, I think we're just not going to use it. Okay. We'll find a different way. Why do they make it so hard, man? We didn't even save it anyway. Okay. So this is a header only one, which is nicer. This is a bit more of a nasty library though. That ID documentation. Right, we could just make our own file format. It will be fine. But any other 32-bit floating point image formats. This seems way too complicated. I'm just gonna make my own format. That's gonna be fine. Okay, so we're just gonna do struct imf32 header, and we're just gonna go u32 magic equals if32 and then we're going to go U32 width equals 0, U32 height equals 0. And that'll do. I'll do. So what we want is just to copy an image writer. So I might as well just copy this. This is IMF32 image writer. And we can just push onto it. So we're just going to go IMF32 header. And so header dot width equals view dot width. Get width. Header dot height. View dot get height. We'll say that'll be fine like that. That'll be fine. Okay, well the line is 16. So we just do buffer push header. And then we're just going to do buffer dot push view get pixels, is it? View dot get pixels. And just return true. So we're just going to go im dot write to file IMF32 image writer for top, what is it? Test dot IMF32. All right. So that saves it out in theory now. IMF32, it's only 1K though. That's not correct. Let's try that again. The view, it's not quite as simple as that because it could be a box inside an image. Oh, it's not pixel size bytes. That's the size of a pixel in bytes. Just get size bytes. But it's not quite this straightforward. It's do we have view.getRect? get bounds. So auto bounds. Yeah, so this is actually bounds dot get width or bounds dot width. Bounds dot height. And then we need to actually push on the box. So just 40. Start is bounds.x, bounds.y, bounds.height, y++. We want to do pointer is equal to view.get pixels plus bounds view.get width plus bounds.x and auto pitch. Let's get pitch in it. Okay, so I just want to do pointer plus equals view.get pitch. I just want to copy a row, so it's buffer push pointer bounds.width times for I think we could actually cast this up to a float, really. Say float. And we can just do this. And the pointer plus equals view dot get width. I don't know whether that will actually do this. Will actually take into account the pointer value. Yeah, it should do. Should do. We don't actually need to push So this will push a region. We don't need the Y++. This will push a region inside an image, like a square inside an image. So reinterpret cast. It's just 4:2. Okay, let's try this then. Okay, so that's the first pixel in the image. All right. There we go. It's not compressed. I mean, we could compress it. We could do compress LZ4 compression. So really this needs to be pushed into a separate buffer. So we're just going to go T push buffer, data buffer, get data, get size, and then we just want to go buffer dot push the data buffer, get data. No, what is it? Is it the compressor result buffer? Does that return a buffer? Data compress buffer to get size. Is that actually how that works? No. It does return a buffer view. Oh, it needs an allocator. So we'll just say T temporary was it temporary just do buffer allocator, T buffer allocator. Right, let's see what happens there then. Push a bunch of stuff into the data buffer, compress it. 7.6, so that's 7.6.4163, and the data buffer is, so it's actually quite a lot smaller, I think. So we were about 1.6K before. And it's 747K now, so that's good. That's made it smaller, which is nice. So what we need to do is we need to say if bounds.width equals view.getWidth. It has to be like this because this view might come from a different image. It might be a smaller section of an image. I'm going to say we could potentially have a faster path where we don't have to do this loop, but it'll be fine. So we have our IMF32 image writer now. So now we need the image reader. Hi, Fu Manchu. Hey, how's it going? Hope you're all right. I'm just writing a little image type to store. It's like single channel float 32s. That's what I'm doing at the moment. Hope you're all right. Hope you're doing well. You might appreciate this. I did a cool thing the other day. So you can do something like, well, let's go into the other, well, we can go into here. So you can do something like array eyes 1, 2, 3, 4, 5, and then you can go j's equals eyes dot copy. What is it? Eyes dot copy if, and then you can put a lambda, right? So it could be something like I could call this like arg. And you could say like return arg is greater than or equal to 4, for instance, which is the normal way you would do it. So it's basically copy everything, so copy 4 and 5 out of the array. But I made a cool thing where you can go using namespace logs, and then instead of this lambda, you can just say arg is greater than or equal to 4 like that. And that's the same. I saw this in Boost and I was like, how are they doing that? Want to swap tasks? I do not want to swap tasks. No, thank you. So like this is like, you can construct a lambda out of a binary operator. So there you get 4 and 5. And what's cool is you can do something like or arg equals 2. So you can like change them together, chain them together. So now you've got like 2, 4, and 5. And it doesn't have to be integers. It could be literally anything. And this lambda could go literally anywhere because it's just a lambda. So you could imagine like this could work on a whole bunch of stuff, and it's like nice and straightforward. It's called in Boost, it's called Boost Phoenix, I think. I don't know if they've I didn't look at their implementation. I just saw it on someone did it like did like a post on Stack Overflow, and I was like, how are they doing that? So I spent some time so their implementation might be quite different to mine. Just like exploring building lambdas out of overloading binary operators. And then you can have so it doesn't actually even have to happen. This only works with one arg. So you can imagine that this arg is like each element of the array, but some lambdas might take like 2 arguments. So you can do like arg0 and arg1. Like this won't work for this case because it only works. But you can imagine you have some data structure where it takes the example I had was merging 2 arrays together, and you could say how you want to merge them. So it could be like arg1 plus 2 times arg0 plus 2 times arg1. So it will put the first element, the first array, times plus 2 times the first element of the second array, and it'll go through like that. And that is all supported. It won't work on copyif because copyif is only a single argument lambda. But if you had the merge 2 arrays example or something, it would work. Then you can have as many arguments as you want. So you could just say arg17. It's really cool. And there's and or. And you can have as many as you want and just chain them together. Boost Phoenix, yeah. I didn't look at it. I haven't actually looked through there. I just saw that little cool thing on Stack Overflow where they were so I'm not entirely sure if it's the same. But yeah, where they were just doing this type of thing, shortening them. And then you can do arg with test, and then you can pass in your own kind of. So it could be something this could be NPCs, and it could be last NPC to die or something. So it would copy over the NPC if it was the last one to die. So you could link it up with game state and stuff like that. And that's just a lambda, so it'd be last NPC to die, and then you'd just have bool operator const NPC, and then you would do the test there, and this NPC would be it'd cycle through, so it'd give you every NPC in the list. So you could put separate tests, and you can chain them, because you could say or arg equals 2. It's pretty cool. It's just a really neat way of thinking about it, I think. So you don't have to write the entire lambda out. But yeah, today I'm fixing up the lighting. Not the lighting algorithm in the shaders, how the game editor builds lighting and stores the lighting on disk and stuff like that, because it was working, but it was written a couple of years ago and it's quite buggy actually, so I'm going to strengthen it up a bit, and that means creating some image format to just store floating point arrays of an array of floating points numbers, which is the light's distance field. So I'm just making I'm making an im f32 writer and an im f32 reader. At the moment. So I just want to read it back out again. image reader. Enjoy, Fu Manchu, enjoy your code review of 401 files. That sounds nasty. Adding a render command queue. Oh, cool. Queues up commands, yeah. Yeah, that's how this one works as well. It queues up commands. It's got several advantages, I think, because you could store that command queue away. And then, so if you know that you don't need to change what's being drawn, you could store that command queue away, say, and then you could just submit it to the renderer without having to add everything into the queue. So it can be quite nice, saving quite a lot of work. It does it through the canvas. So you create a canvas object and then you like draw things with the canvas, but what's happening under the hood is it's actually building up a list of commands and buffers and like vertex buffers and stuff. And then that just lives in memory until you delete it or you restart it. So you could populate it once and then draw it many times in many different areas of the screen or whatever. So you could draw it on 2 areas of the screen but actually just populate the buffer once, which is kind of handy. But yeah, I think that's a good way to do it, definitely. And then, you know, if you have a serialization system that in your engine, you could actually serialize that command buffer over a network if you wanted to, which would be cool. So then you could have like one computer drawing things on another computer. This would be quite nice in some situations for like code collaboration or whatever. Or you could serialize it to disk. I don't have a separate render thread though. I don't do that. In theory, I could do that. I might do that if it ends up getting too... I don't think it's ever going to be a problem being too slow. But if you're going to do a lot of drawing, the render is in 2 parts, so you could have that exchange point where you could like build up your command lists while you're rendering your other command lists and swap them. But I don't do that at the moment. Command references, assets. Yeah. So I have a thing called a residency to handle that. And the residency keeps track of what's resident on the GPU. And the render at the beginning of the pipeline is free to submit things into the residency. And the end of the pipeline, so like DirectX or OpenGL or whatever, is free to evict things from the residency. And the residency just controls if it's there or not. And it just gets a handle basically. So when you want to actually draw something from the front end of the renderer, you get the handle from the residency. And as long as the text is valid, it will always return a handle. And then when the back end of the renderer scans the residency, it looks to see if it's on the GPU or not. And if it's not, it will submit it to the GPU. And not draw it, essentially. It just submit it. It'll just be like, right, this texture's not on the GPU. I need to put it on the GPU instead of drawing it. And then the next frame, when it comes around, and you do a drawing again, it will be on the GPU, or 2 frames later or whatever, so it will end up drawing it. Swap the queues. Yeah, cool, yeah. Yeah, I found that the residency thing's been pretty good. It's been a good solution to maintaining the assets across different sides of the renderer. Because it doesn't have to be textures. You could do it for if you wanted 2 buffers as well. I don't do it for buffers. I basically create the buffers every frame, and then like the vertex buffers, and then if they're on the GPU, throw them away already. Which is a tad wasteful, but it's so far been really fast. You can't really determine, you see, in advance if this buffer is going to be the same. You have to build the buffer and then check it's on the GPU or not, unfortunately. Oh yeah, you can put Tracy in. Yeah, the profiler, yeah, nice. Yeah, I hope you're having a good time with it. It's really fun getting the beginnings of a renderer going, I find. Even though, like, so I didn't use any like libraries, so it took like, it takes like a month before you actually see a triangle, really. But I found that really fun, like thinking about, well, how am I gonna check if stuff's on the GPU or not? How am I gonna allow the GPU to evict stuff if it needs to? Because Windows could come along at any point and just be like, you need to take stuff off the graphics card or we will stall your game. Like, it can do that. So you have to, like, it only gives you like a few frames to sort that out. So it's quite fun dealing with all that. It was good. You know, if you're playing your game and then all of a sudden the computer starts up like Red Dead Redemption 2, Windows goes, you need to get some stuff off the graphics card right now, because we've got loads of Red Dead Redemption 2 assets coming on. How is the allocator concept implemented? Oh, this. It needs a malloc and a free. So I have 2. I have static, like this, which is more STL. That's kind of how you do it in STL. And then non-static, which is like this. So it's like you need one of them. So you need it needs to have malloc, which takes size T and returns something that's like a U8 pointer. Quarton, how's it going? Raylib. Yeah, cool. Yeah, I've seen a few developers use Raylib. Never used it myself. Most of the actual things that need to allocate use this one, a static allocator, but there's an allocator as well, which is what this uses. I don't know if I'm just about to write this. I don't know if it is going to be a static allocator or not. Quarton. Concepts are really handy, I find. I find that they reduce a lot of boilerplate for setting up things. You know, like on the gameplay, it's in a different project actually. Different solution. So I'm making a game, right? So there's gameplay systems, obviously, And then these are all the gameplay systems that I put in this list. And then I can have a concept which is like, is a gameplay system, which is just like the type system is in the tuple gameplay systems. And then I can use this concept everywhere that I only want to accept gameplay systems. So it saves me a lot of writing. So it's like, you couldn't call tick on something that's not a gameplay system. So they are really handy. I think they're quite a good addition to the language. And I use them to exclude code as well. Like, you know, if you do like if, like hashtag if, and it would exclude code. So you can do the same thing with concepts, but you have more context available because you have all the types of your program to determine if you should exclude this code or not. Do you know, does that make sense? Try and find an example. The entity state controller, does it? So I have like, if entity has on spawn, which means the entity has on spawn implemented. If entity doesn't have on spawn implemented, entity type T, this code actually gets compiled out, and so it means that if I want to make an entity and it's not going to spawn for some reason, I don't know why, I don't actually have to write the spawn function, and it still compiles if I don't want to. So you can use them for that as well, which is cool. Right, relibs them. How big is the compilation time for them? I haven't measured an actual concept, a single concept. This whole engine takes about 1.5 minutes at the moment, but this is a 10-year-old computer. And the engine's quite big. I'm not sure how big it is, but it is quite big. Does a lot of stuff. But I'm not sure about the compilation time. Not sure. There will be an impact for sure, as anything with templates is a big impact. It's a flexible thing, but easy to get something on screen. Immediate mode API, like, oh yeah, cool, yeah. Sounds interesting. And does it support like OpenGL and DirectX and Vulkan and everything? I'm just about to build a new computer actually, because this computer's old. I'm going to build one next month. It will be really interesting to see what happens with the build time for the whole thing, because it is getting in the way. I'd say now we're at a size where the build time's getting in the way. All right. So we want to read this back out. So how do we even do this? We need a binary reader. So it'd be something like auto header, IMF32 header. So we'll get the header out, and we'll just see. So we're going to go im.read from file IMF32 image reader test.imf32. Must return a value. We don't need it to return anything at the moment. Let's see if we get the header back out. There it is. 640 by 640. Does that work? No. So we want to say if header magic is not equal to IMF, was it IF32, was it? And we'll just make a result. Let's return the empty result. So we need to make an image view. I haven't done one of these readers for ages. So we'll look at the raw image reader because that's probably more similar to this. So it wants me to put the actual image data there. That's fine. So we need U8, well, we'll say float pointer data equals reinterpret cast float pointer allocator dot malloc header dot, thinks it's optional. Maybe it is optional. Oh, it's a read result. Say if not header. Oh. Yeah, Quart and my Fu Manchu streams as well. He streams the making of this. This is cool. So you want header width times header height times size of float. So that is our data for our image, right? So I think actually here, the header, we need compress size as well. Header Quantum, thanks for the follow. Yeah, Fu Manchu streams after I've gone to bed usually. I will get on live one of these days when I'm still awake. Compress buffer.getSize. Right. So now we have the compressed size. So we need a decompressor. Decompress. LZ4 compression. LZ4 decompression. And it needs the dest size, which is this. The source is get pointer header compressed size. This probably also needs a buffer allocator on as well. See if that builds. Normally until 1-2 AM. Yeah, it's a tiring way to code, isn't it? I have no bills. I live in my computer office. No, I do have bills. Unfortunately. How does a decompressor work? Oh, it has a buffer. A result buffer. You can tell how often I use these decompressors. So maybe this is just a tpush buffer. Decompressed data. I live with my parents. I don't live with my parents. That would be, my parents aren't together. My parents are divorced, so that would be, I'd be living in 2 houses. But no, I have a wife and a child and a family. It's an expensive world out there, though. I wouldn't, if someone was still living with their parents, I would totally understand. It's expensive in it to live now. How does this even work? I haven't written a decompressor in this engine for ages, or worked with it. Let's have a look. Decompressor. Data. What is data? Asset data. Data is a buffer allocator. Of course it is. That built. Let's go. That can probably actually decompress straight into there. That's probably how that's meant to work. See if that works. And that means we don't actually need this. Vanberg, hey, how's it going? External dependencies besides STL. I use not much STL actually. Standard optional is a big one. Standard span is a big one. Standard array sometimes. It's kind of it really for STL. I have these third-party libraries. So BC7E, so that's an image compressor, a block image compressor. Dr. Wav. Although I don't think I actually use Dr. Wav. It is in there. So I have my own WAV sound reader. It's maybe to write WAV files, maybe. I don't know if it's even actually used. Oh no, here it is. So I have a WAV sound reader. Then I have a 44,100 Hz 16-bit WAV sound reader, which uses Dr. Wav, resamples it. So I think it that's to make sure, I think, when I'm building sounds for the game, I resample them all to the same size. I think. It's very old, that. I have LZ4 for compression. Magic Enum, which is enum to string and string to enum conversion. Rapid CSV reader. These are more block image compressors, and then I have some STB stuff, so like images and stuff like that. Standard is digit. Standard is digit. I might use standard is digit. Probably don't. I've not heard of it, so I'm not sure. And then I use a spine animation library as well, but that's not in here, that's in the actual game engine. This isn't the game engine source code. This is like a little Scratch project where I build stuff for the support library for the engine, so I don't have to recompile the entire engine all the time. Because I'm doing like image readers and writers now. This is going to actually live in the actual my STL, you know, the STL that I've written. Use it for tokenizer. Alright, cool, okay. Let's have a look, see what it is. Is it just, if it's a number, is that what it is? Alright, one of the 10 decimal digits. Okay, yeah. I'm not sure if I use that. I'll probably just test if it's between the car number 0 and the car number 9. Okay. So in theory, this is the decompressed in theory, this is the decompressed image. So what we might do is read this again and do just memcomp. Just actually see if it's the same. It's already there, yeah, exactly, yeah. Exactly. So if this has worked, RE should be 0. It's 1, which means it hasn't worked. Unless I've changed that. No. Does memcamp return 0 when they're the same? Yeah. They are the same size. There's a bunch of stuff on the front there, though. Oh, that's the compressed version. It does decompress. All of it. So let's just have a look at buffer dot what's it? Buffer dot pointer. Buffer dot data. Okay. Buffer dot data dot pointer. Let's have a look at the first 10 of them. And then allocator data. Pointer. They're all the same. Alright, we'll do it a different way. We'll find the first byte that is not the same. If buffer.get data d is not equal to allocator.get data d, break. Is alpha number, yeah. Cool. What is D? 640. That's interesting because that's the actual width of the image. 640, the width height of the image. Interesting. We'll say 635, and then we'll look at 10 of them. So it gets to this number 64. And then it's all just different after that. Okay, so let's have a look at this data buffer. So this is data buffer, data pointer. So 640 is D. So remember it's D. So this is the actual oh, it's the buffer that's wrong. This looks right, D. But the buffer was the one we read off the disk. Okay, that's weird. That means we compressed. Or we loaded the image wrong. The view was wrong. I'm a bit confused. So this allocator is the result of the decompression, and this matches correctly before we compressed it. But then I've just loaded what we've compressed off the disk, and that's different. That's so weird. Okay. Like it matches. The code, I think what it is that the compression decompression is fine. It's when the data gets passed in. So let's have a look. It's just 640 we're worried about. Is N there? So the buffer is N. So that's what's read directly off the disk. It could be the raw image reader that's not working. So let's just look at what is pointer. It's void pointer. So let's just look at U8 pointer 640. N. Cosmic Husky, hey, thanks for the follow. Got any questions, just ask, no problem. I met my follower goal as well, awesome. Thank you. So that matches. Okay. So it's this reader, I think, that's not. So that's N currently. So pointer is N. So what is the reader doing? Okay, so this raw image reader isn't working. Basically, it doesn't know how to load in 32 images. So the pitch is 2560. The dest pitch should be the source pitch, really. Width times channel count. You know, this was used for this is meant to be out for RGBA images, really, or grayscale images. We need to kind of extend this to work. For floating point. it might just work if we actually say that the channel count is 4. It's not, but it's the same size. It's only got one channel on it, but it's a full 32 bits of one channel. They're both N now, which is a good sign. And now that's 0. So that's working. We just need to put the 4 there. It's not the best because there's not 4 channels in it. There's only one channel and it's a floating point 32-bit channel. So I'm wondering if we should change this API a little bit. But now we have the reader and the writer. We do need to turn it into... Yeah, this does need to work, actually, because we're going to actually have to turn it into an image so we can write the IMF32 to disk. So this pitch here is actually the source pitch. Really? Which they all are. Width times channel count. I wonder if we would just say that they've both got the same pitch. So that's the source width, the source height, the source channel count, the source pitch. Okay, I think what we probably need to do is we use 16 bits per pixel like this. Really. And they all need to be 0. Equals 8. We'll just have to check wherever we're using this raw image reader. We probably are using it in other places because this has changed now. So we're going to say auto pixel, or what we're going to bytes per pixel equals bm bits to bytes, bits per pixel, and that's times bytes. So whenever we see channel count, width, height, depth, XY, pitch, bit depth. So depth is 1. 0, 0. Pitch, bit depth, bits per pixel. So this is like saying if the pitch that we want is the same as the pitch, we just do a straight up copy. So that has to basically do this as well. Else, if the source pitch is different from the dest pitch, we need to copy one at a time. Okay. So now here, we can actually just say there's one channel, and it's 32 bits. Left hand side, right hand side. How does this even work? What is this doing? Why is this doing that? No idea. Just make this size T, it's fine. Alright, so let's see if this works. Nope. Okay, it's actually U32. Can just be U16, that's fine. Got linker errors now. For the locks. Let's try that. No. What are these linker errors then? Let's rebuild. That built fine. I'm not sure what those link errors were. Okay, so let's just see then if we get the right. So it's one channel, 32 bits per pixel. PPP is coming through as 0. For some reason. So strange, isn't it? So if that's 0, that means this pitch is going to be 0. Why is that coming through as 0? I'm going to have to just rebuild this. It says it's 32 there. This is kind of broke. That is 32. It thinks it's this off because I've called it the BBP. It's a typo. There we go. Okay, so now we're 32. Now we have the right pitch. So that actually isn't times bytes per pixel there. It's just here when we have a different dest pitch. That's 0, so that's correct still. So what I'm going to do is go back to, because I've changed raw image readers API now. So I need to go back to the game, actual full engine code, and just check anywhere that's using raw image reader. Hopefully it's not everywhere. Content browser. So token dot, do we have bits per pixel? No. It's 8. Bits per pixel is kind of the wrong name as well. It's not bits per pixel. It's do we call it? Bit depth. We could actually put them in the tokens, you know. Yeah, we'll do that. Is this type of token a readback token? Readback token depth. It's just there. Canvas to memory readback token. It just makes a readback token. So I think that's totally fine. Whoops. And this is totally fine now. It just needs to return the image view, the proper image view. Pixels. This allocator got that data. Technically, this allocator could already have data in it. So it has to be like this. So let's decompress result. Get data. Channel count. 1. Width is header dot width. Height. Header height. Depth. It's 1. 0, 0. Pitch. So if I put 0 in the pitch, does it actually calculate the right pitch for me? Yeah. Bit depth. Is 32. Image ID. So I was to put nothing for an image ID. Creates a new ID. Maybe I want the image ID to be the decompressed result. Image, the hash of the decompressed result. See if we can just do it like that. And it's grayscale. There's no image treatment. That is a long constructor. The only thing is this. Might need to actually hash between a pointer and a size there. Didn't like it. What's the problem? It says it cannot convert argument 10 from U64 to image ID. Okay, it needs to be like that. Okay. So we just want to look. Oh, the hash is going straight away. Missed it there. Okay. Hasher for a buffer view, so that's totally fine. That did hash it properly. So what is this then? Image 2D size 640, so 640. Bit depth is 32. So it's given them all as hex codes instead of floats. You know, maybe we could fix that. We could give them as floats if the bit depth is 32 and the channel count is 1. So let's have a look at the result. Let's have a look at libm NatViz image view. Pixels. Okay. So we're going to say if condition equals pixel size. I was going to say channel count is equal to 1 and bit depth is equal to 32. It needs to be one of these item things. That's a float. There's no XB there. This is else if. What's the problem? 464 unrecognized token. Okay, so we can't have an AND like this. We need AMP. Alright, pixels. They're all floats there. Awesome. There's not... Is there 409,000 of them though? Not sure about that. Pixels. Pixel. Width times height times depth. No, there is 409,000 of them. Only 46 files to go. How's it going? Is the code good? Oh, is there a lot of work to do? This is going quite a lot slower than I thought it was gonna go. But it's alright, we're kind of finished with this now. Okay. And there we go. With all our floating point pixels. So now, I began the stream by trying to find an image format that supported 32-bit float. And there's only TIFF that I could see. And then I tried to get tiny TIFF, which turned out to be not so tiny and quite difficult. TIFF would have been nice because then we could like open it up in Photoshop and stuff. But I couldn't be bothered to mess with. One of the reasons why I don't use a lot of libraries is because coding becomes unfun. Siri's talking to me. Coding becomes not fun sometimes. But maybe another day I will add TIFF support. I'll actually put that. I'll put that in the notes, in the to-dos. Add TIFF support. So it would be nice because that means that if we do add TIFF support, it means that these light files could be opened in stuff like Photoshop. I'm assuming Photoshop can open TIFFs. It's okay. Right, okay. That's bad, isn't it? Yeah, a lot of stuff. Well, only 46 to go. Yeah. One of the big perks of working on your own is no conflicts. Does it open TIFF? TIFF, yeah. So we could open it in Photoshop if we did do TIFF. Does anybody know of a single header TIFF reader writer? Do you know that, Fu Manchu? Is there any library out there that is a single header TIFF reader writer? STB image, yeah, I don't think it does. I did check that. Or it might do, but I need 32-bit float. We do have, it says .tiff there. And that's the only place in the document that has TIFF in it. Image right. TIFF. No, nothing in there. Or any other file format that supports 32-bit float. Like, I don't. 256 colours. Had to share it. Yeah, I know. Yeah, it's mental, isn't it? The float. It's not actually a texture; it's an image texture. That's why it's a distance field. So it's actually a bunch of distances. But I think like it doesn't have to be a TIFF. I've just written my own F32 image format, but if I did it as a TIFF, it means I could open it up in Photoshop and look at it. So I could check that the actual light files were valid, which would be nice. It was actually a distance field. I've put it on the to-dos anyway. Well, we'll work on that at a different time. Okay. So we're just going to put these in their own IMF32 reader or writer. I just call this writer reader. Wherever it is. Because it's got its own header. It would be nice. It would be nice to actually have a limitation like that from an interesting coding point of view. To have 256 colors. When you kind of like don't have to worry about precision as much. Makes it a bit easier, really, doesn't it? You still have to kind of worry about precision. There is only 8. There is only like 1 byte per color channel, so it's not actually. It's only 256 different levels of red. So if you've got like a solid red gradiented background, you would see that on a big monitor. You would see the banding. So it's not quite solved. You'd have to dither it or something. Okay, so we actually need to include in here. Right, there's a bunch of stuff in here that we are using. Right. There we go. It's in the library now. So that took me like 3 hours. It's a lot longer than I thought. Okay, so let's go back to the game. So where were we? We were in something to do with sprite sheets. So all I'm going to do, I'll just build this and then test. Oh, we can't build it. Oh, look, we deleted a load of. Deleted all the equal signs. We'll just test it actually builds and runs, and then we'll check in, and then we will make these light files. While it's building, I'm going to go and make a cup of coffee. I'll be back in 2 minutes. Okay, we're built. Just run this. Check we don't crash. The only thing we've actually changed really is that raw image reader thing. So we could test that out. That's used on the readback stuff, which is we need to load it to a different level because there's nothing happening in that level. So if you just make a save and check the readbacks are working. Yeah. So the readback requests make these little thumbnails here, and that was what was using the raw image reader that we changed. Okay. We'll check that in then. And we need to go back to the sprite sheet editor, particularly where we were actually. So this now is not going to be a light file. It's going to be, I don't know, IMF32. File. Image float 32. Are we using .light anywhere? I've anywhere to request a. No, I'm not using it anywhere. I'm not actually getting anything by file name as a light, which is good. So we can change the. We can just go ahead and change the extension of the file there. So rather than literally just read and write here, we're going to go. We're going to make an image, and then we're going to go read from memory raw image reader. Width, height, channel count. So this is layer distance field dot width, layer distance field dot height, channel count, bit depth, like this. And the actual memory is layer dot distance field dot buffer dot get data, layer distance field buffer size, and then we actually want to write it im.write to file layer path is the file name. We want a IMF32 writer. So we want an IMF32 writer. It's a raw texture reader with ID as well there. So we probably want an IMF32 reader with ID. What is this distance field? It's to texture. So I think actually it's a different thing. It's image im dot read from file. No, read from file. Or read from memory. We've already IMF32 reader. Buffer.get data. Buffer.get size. And then this load from memory is a texture reader, but using the image instead of the layer. Yeah, I mean, that means we don't actually have to store the width, height, and format as well, which is actually one of the things we wanted to get rid of. So this is im get width, im get height, and the format is texture format F32 or R32. I think. Let's just check. R32, yeah. And this is im get pixels. Get, what's it, size, bytes. So that's like a copy, and a copy probably. So there's 3 copies there, so we could get rid of that. Okay, let's get rid of some. I've got a few of these windows open. So what we need to do is we need to delete these light files. Where are they? Levels, but sprite sheet. So we need to delete these. These are not going to be lights anymore. These are going to be IMF32. I'll build all this. So we can cut out one of the copies by loading it directly from the layer. I don't think we can really, we have to copy again because we're going from an image to a texture there. And we haven't got to move. Okay, we'll actually do that first. This can be read from file and the file can just be the layer path. To be fair, that might fail. So these should fail because they don't exist, these files, at the moment. So I just deleted them. Looks like it didn't even build, which isn't great, is it? So, assuming this works, that means we can knock out, we don't need to store the width and height and format in the actual sprite sheet file itself. So we're working on like the light sprite sheet. It stores width, height, format. We just store a path, and that path is to the F32 file. So that means that the levels that include this sprite just need to store the path to the light file, which is the goal really, rather than, because this was just like width, height, format, data. Now the problem is if I then go back to the sprite sheet, regenerate lighting that's a different size, it wouldn't actually load, it wouldn't reflect in the levels because they'll have a different width, height. The format will be the same because it's always R32. They'll have a different width and height potentially, and this solves that problem because it gets it out of the file itself. Okay, so we're in now, we've built in. So there shouldn't be any lighting at all, which there isn't. So if we generate lighting now, we'll save the light file. So we read with the raw image reader like we were just doing in that test. And we write it out again. And then we're going to read it back in immediately. Oh, we called it .light though. What did it actually save? .light, maybe we didn't change. I'm sure we did change. Oh, I know what's happened there. It swaps the paths over. Try and keep the paths the same. Okay, so we don't actually want to swap. So here it's try and keep the old ID and the old path. It swaps them over. I don't think I want to do that right now. do want to do that, but not right now. Okay, so the path now is an IMF 32. That's cool, that's cool. So the big test, I suppose, is if we load this up and the light is still there. Which it is. Let's just check the code. So it went through the raw texture reader fine. Oh look, there's a shallow. There's a shallow copy. Oh, then it does a deep copy. What is it doing here? This is a text to view. Oh, then it does a deep copy. Brill. So if I like change it up to like have a radius of 20, regenerate the light. So that's the next bug, is it's a bit off center. I want to do it with a bigger radius for some reason. About 15. That works. 18. That works. 19. That works. 20. Now that works. Weird. That is weird. Because we're not swapping the paths over, it probably created a bunch of lights. Oh no, it didn't. It might make a lot of sense just to call them dot lights still, you know, because the reference is dot lights all over the levels. Well, I'm gonna have to change that anyway though. Okay, cool. So we'll leave that at 10 and we'll generate. And it built this light file, and this name of this editor window layer. So the light.spreadsheet. Spreadsheet, the light.sprite sheet actually is this, and the ID is this. So that's saved properly. So what we want to do now is in the sprite sheet editor, I want to go back to swapping the ID and the path over. And then we'll just have a quick look at what is going on there with them being off center. Because I rebuilt it, so one of the things I noticed was it was off center when I dragged the mouse. If I drag it, I wonder if it's actually changing the origin somehow. If I put 20 and don't drag the mouse, that just works. But if I like drag, it's taken a long time to generate because it's a big light. There we go. Look, it's made it off center. So is it the act of dragging that did it? How big is that light file? 73 megabytes. Alright, let's put it back to 10. So if I do that, that's fine. But if I drag it, well, that's crazy. Undo actually works with the undo works. The problem with that is it might not work from the file point of view. That worked. Why is it sometimes? So there we go. So if we drag it not onto the canvas, so it seems to be so if we just type the word 20, here we go. And let's just look at this light. It's the stats of this light. It's basically like the local bounds and the local offset, really. Okay, and then if we go back to 10 and then we pull it up to 20, didn't work. Now it's behaving. Can't get it on now. Come on. There we go. I don't know, now it's working fine. Let's relaunch it. Well, it seems to be working. It's a shame. It's a shame. Now it's generating in the right place. Okay. Let's go a bit bigger then. 31. Now it's the wrong place. 31.9. Okay, so let's... This is the wrong location. Don't really want to save it, to be honest. So it's 31.9. So let's copy that. So that just generated in the wrong location without even having to drag it. So it's not the drag. Let's type it out. 31.9. Let's go back to 10. 31.9. Right, so that seems to always be off. Okay. So this is to do with, I think, we're just drawing it in the wrong place. So basically these values are wrong. It's good to get one that's not a point. So let's just do 32. That works. 32.1. Ah, it's maybe the decimals. So if I do 10, 10.1, 10.2, 10.8, 10.9, 11. Okay, so it's when it's decimal. So when it's a decimal, I wonder why that is. That we're casting it. So it has to be a whole number. Because we're casting it to a whole number there. No, we're casting it to pixels, actually. It might not need to be a whole number. It just might mean that this has to get cast like that. Let's try that first. Because PPWU is just to scale into pixel space. That might fix that, actually. So if we do 10.1 now. Yeah, so 32.9. There we go, yeah, that's fixed it. We don't want to like that big though. That's quite performance heavy. Alright, cool. Just one little rounding error thing there, which is good. Okay, so the next thing we need to do is these need to go away. So just the width height format needs to go away. I don't actually think we are storing in the width height format. Okay, that's basically all that needs to happen. And that needs to also happen in the levels. So we've basically broken all the lights in the levels. But you know, they're only prototype levels, that's fine. It's just when we save a level out, we need to not save the width height format. So let's go back to the prototype room, which is the light test room. Where is it? Light debug. So these are obviously incorrect information now. We've got board's bright lighting layer. Which does have this distance field stuff, width, height. So how does this work then? That can go away because that's probably been ifed out for ages. That's if you wanted to shadow cloth, which we might. Hang on. So we do draw shadows. It takes the light. Light's not even used by the looks of it. So is this used at all? Here we go. This is in the level generator. But actually, we don't need them. I'm going to try and get away. So it's the same with the pond. Pond must use a distance field as well. We might look at ponds after. I'll put a note for that because I'll forget. Oops. Probably going to be the first one we do after. So I want to take these away. Like that. Let's see what horrible compile errors that leaves us with. And then I might edit the level manually. Take these sprites out. I might just take it all out actually. I wonder if that is actually possible. Could be. Okay, so let's get rid of these compiler errors now. They're gonna come up. So it's to do with this specifically. So this is an image now, so it's the same as when we loaded it before. So it would be if distance field read from file IMF reader what is it? Light dot distance field path. So I think we do want to add it in even if we can't load it. Just add a null texture in otherwise. So this is distance field get width, distance field get height. And this is read from memory. Distance fields get pixels, get size bytes, like that. So that's how we populate that texture now with the distance field. Okay. So this is work. Okay, so this is working with where to put the glow and the shadow. So we've got the distance field index there. So it's auto distance field equals level light. What is it? It's textures. It's level distance fields index of level light. Well, it's just light dot distance field ID. You just find. Hey, all right. Very nice. What is it? Crusade or something? Very, it's very macabre. Okay, so if we have a distance field, and that is distance field. Texture. Width. Distance field. Texture height. So we don't need those members which held the width and height anymore. We can get it all out of the texture. Okay. So we're doing add texture there. Path, width, height, format. The only place that is being called. So that's this one. So we have things called, we have texture of an image source and add texture with a texture view. So what does an image source do? It looks it up if it's a tile texture. But even though it has a path in it, seems dodgy to me. A lot of this code is actually pretty old. Just straight up adds a texture in. So I think this actually needs to be path and ID. Like this. And that goes away. Check that build. Well, that won't build because we haven't actually written it yet. So this is no good where you're doing this. what we kind of need is what we need is an image. So the image needs to, when we do load or read here, we need to check. We want to check if it's PDSD is DDS here. We probably need to check is, because we put this new IMF32. Then we need to include the IMF32 writer reader. So now we can go if auto, well, we're going to go image IM path, and then I'm going to go if image on the reader, and that is im.getWidth, im.get yeah, I'm alright, thank you. You want to get texture format. From an image. This is a standard move reader, and then I am get pixels, I am get size, bytes. So here's the thing, if we fail to read it, we've still made one. So we'll do texture, text. Vossi, hey, how's it going? I am good, at least an IMG. Oh yeah. It's because there's an A in the way, you see. I'm going to say if text load from memory return, so this needs to return the view, so we need to do index equals textures, add, whoops, standard move text, do that. Could do com or CMD. Probably would do CMD, yeah, you're right. Okay. So what's happening there? So this is making an image. This is copying it into a texture, and this is moving it into the array. So I just want to check that actually works. I do like source and dest. I do src and dst. So I do skip letters out. All right. Board's bright lighting layer. So they can go, because the lighting layer, it doesn't have the width and the height in it anymore. Yeah, I do source and dest as src and dst, so they're the same length, just for a bit of neatness. That's the only real reason, because they're both 3 characters. It's not really for shorthand, I don't think. As you can tell, I don't do much shorthand, really. But yeah, src I will use. Index IDX texture text render target view RTV. Yeah, sometimes I'll definitely on the render target view because it's quite a long word. Probably I might do text. Probably won't do IDX. I'd probably just do I. Oh yeah. That's quite advanced, that though. That's, I would say. You need a lot of experience, don't you? I would say, to know how your code's gonna, what's gonna happen to your code as the code base grows. I mean, some things are obvious, but in general, I only do I when outside of a loop. I only do I when outside of the scope of a for loop. For a for loop. Inside the scope of a for loop. Yeah. Yeah. Inside a tight scope, I would say. I wouldn't restrict it to a for loop, but if it was a tight scope with not many lines. Yeah, for int I. Yeah, I have these shorthand ones, actually. For I to 10. But yeah, I would do it there, definitely. But if it's a short scope, like that would be all right. Like I would often put X there. I tend to use X for, you know, inside a short scope of a lambda. So we use IDX. Yeah. GPU state guards like this. Oh, I see. Oh yeah. Not a fan of that. Not a fan of that. And it's missing. Oh, right. I'm generally not a fan of like begin and end. Or does that state guard, does it pop off when it goes out of scope? I've not heard of OpenGL state guard. Not heard of it. I've not done much OpenGL. I've done a bit, but VK OpenGL state guard. Ooh, Google can't find it. Oh, is it your OpenGL state guard? Oh, I see. I see. It's doing it in the wrong place. So what's the problem here? No idea what he's complaining about there. Guard has to be inside. Yes, it's like a scope thing. Yeah. That's just a typo, innit? Has he done it everywhere? So it's like an if, he's thinking about it like an if statement, where you put like the thing at the top and then the scope underneath. Yeah. I do wish there was that kind of mechanism, wouldn't it? Wouldn't that be nice in the language if you could do that type of thing? Because that would be nice and neat, wouldn't it? Yeah. It tends to be a novice programmer's thing, I think, where they'll criticize style. And that's only because they're novice and they only have a small idea of what style is. And you think, you know, programming with the style is programming because that's the style that they know. But then as you do more programming, you tend to lose that attitude. Yeah, everyone's a different level. I agree. And the point is, coding's meant to be fun, right? It's not meant to be a judgment of anything. It's just meant to be people. It's meant to be expression, I think. Obviously, if you're on a team, you all need to kind of express the same way so you all understand each other. But it's an expressive thing. It's like criticizing someone's painting. If they paint different style to you, just You really long variable names to be descriptive. Some really great programmers do that as well. Some really great programmers do 1 or 2 letter variable names for everything, including function names and everything. Yeah, follow the style, because it's a team thing, isn't it then? It's like everybody needs to be able to just read what anybody else has been doing and not put that extra mental barrier in place. Because, you know, you could read several styles. It would just be a lot more work, wouldn't it? It'd be a lot more tiring. And then eventually, if you just write the new style enough, you will just get used to it, and it won't take very long, probably. Alright, that built. So we're not using... Well, we've completely deleted anything in the debug room file, so I wonder what's going to happen. GNS prefixes for global and static. Yeah, I do. So I do capital G for global. No underscore. Don't do it for static though. Don't do anything for static. I don't really have static variables in the class sense. I don't think I have many of them going on at all. I don't really use singletons or anything like that. I tend to just have a get call. Use explicit this. Oh, you mean you do this and then an arrow? Yeah. I don't do that either. Should do that probably. I have quite a nasty habit. Which I don't mind, but I don't think... I tend to name these the same as the members. Do you know what I mean? They're all the same name. This is actually the constructor argument, and this is the member. I tend to do that, which is probably bad, but I don't mind it. It means you don't have to do like underscores or anything. You don't have to have a separate convention for your actual. You don't have to do M underscore or underscore here or whatever. So it's a bit kind of quicker, maybe. This is implicitly defined. It doesn't have to be anymore in C++. Did you know that? It doesn't have to be implicitly defined. You can do do that if you want, and then you can rename it to like self, like in Python. And then it's explicitly defined to be self. Only define that there's not in the scope. There's no possibility of shadow naming. The only problem with you might come across with shadow name is if you don't set it in the get back to where it was. Where is it? Image view. if you don't set it here and you filter it in here, there's a problem. So I'll use the explicit this there, because I don't think the compiler, I think it picks this one, not your member. So that could be a source of bugs. That's probably why it's a bad idea if you're, for a few, you know, if there's a few of you in a team. If the name of the same shadowing can occur, explicit this, if you if you're setting the member variable in the same as the constructor, yeah, you need the actual proper this. If you're in the actual body of the constructor, if you're doing this type of thing, you don't need this, because the compiler knows that the left hand side is the member and the right hand side is the argument. But if you're in here, yeah, you do need to do that. Yeah, you don't have to worry about spam. I'm here for ages. I'm here till 5 today, so I'm not going to be able to code all day because I don't have the stamina for that. So talking is good, gives me a break. You know, this is like a lesser of two evils, because like I don't want to have two separate names for the same thing from a brain point of view. So, you know, people put M underscore, or you could just put an underscore. I don't like that really. And I'm almost always setting it like this. This is a special case because you might pass in 0 for pitch or different channel counts. Yeah, so I don't use the underscore prefix. That's what I'm saying. I don't really like the underscore prefix. I don't like having two separate names. So that's why I name them the same. You know. And as long as you're just conscious about what you do in the actual body, it's only shadowing in the constructor body, nowhere else in the class. So as long as you're aware of that, like I don't tend to mess this up, but obviously if you were just coming onto the project, that might be a big source of bugs, or could be. Underscore lets you know it's definitely private. Yeah. So I do sometimes use privates for members, but not often. A lot of the time, like here it is private, I think. Yeah, well, it's protected anyway. A lot of the things, I leave everything public. Unless it has to be private, because if I set it outside the scope of the class, it'll cause a bug or something. But most of the time, everything's just left to be public. I mean, maybe not most of the time, like 70% of the time. Like, I'm quite a fan of the C# way of doing it, where you have properties. I think that's quite nice. Like, I wish there was something like that in C++, where you define, like, here, you do something like public vec2, and then you can do like get private set like this, and you can do stuff like that. I quite like that. Yeah, ceilings do getters and setters. Yeah, that's one of the reasons why I keep everything, or a lot of things, public. But you know, I do getters and setters as well. It depends on the actual It depends. Like this is just using the members, but I think it's just because this is friended. This is a friend of the layer. Or maybe the layer doesn't, I don't know. No, the layer is just a structure. So yeah, I'm not doing private public things there. Even if there was methods in here, I wouldn't have private public. See, here's a method there, there's a constructor there. Let's just set some default values. Although, this was written a long time ago, I'll probably just set them right here now. Do you use has, should, is before boolean variable names? There are instances of both in the engine. I used to do it, and I'm slowly transitioning away from doing that, I think, now, style-wise. But yeah, I used to do it. Alright. So we generate some lighting. So if we launch the game, there's nothing there because we completely deleted everything out of this. Oops. Just closed that by accident. So what we need to do is open that up in the editor. And just put a light back in. Save that. And there we go. So it's using the it's using the IMF32 file now. So what this means is I can make this bigger, so like 30, generate the lighting for that. This is a much bigger light. And now, is this actually going to recognize? No, it's not. So we need to actually make the level itself so this automatically loads the new light. But if we do actually just restart the editor now, it should, the new light should be there. Instead, I just have alive, and then the getter will be is alive. Okay, yeah. The function and the variable. Yeah. So there's no light there. Whoops. Is there a light in the room file? There isn't a light, so that didn't actually work. Oops. So it must be referencing a different. $6950. So it is the right. It is the right one. So that's to do with maybe the way it's been generated. Yeah, I'm becoming quite a fan of kind of shorthand. See, I don't like, there's get count. It could just be count. Get doesn't do anything there. The only thing is that, like, this is like a verb. Could be a verb. Whether it's not really. This is not doing anything. This isn't counting the textures, if you know what I mean. This is just returning the count. So I'm undecided. Yeah, that's what yeah, sometimes it could be calculating something. That's what I mean. It's like the standard vector empty, isn't it? Empty has a different meaning. Like, are you emptying the vector or is it empty? The two have very different consequences. Calculate the count and return it. Yeah. I mean, this just returns the count. But yeah, like if it was just the word count, that's probably why size is better, because in standard vector it's size. But the problem I have with size is it's ambiguous, because if you do size of something, it gives you the size in bytes. So when I do size of a standard vector, it actually means the element count. So it's like size is better than count because size is not necessarily a verb, but then it's not better because you could be expecting the size like in size of. They have size and capacity, yeah. But what I'm saying is it could be count and capacity. Because size, to me, is the size in bytes. And I think they have a separate one for size in bytes, don't they? A size is like a byte thing in my brain, I suppose. It's not the number of elements in a vector. That's the count. Use count or amount typically over size. Yeah, me too. I don't usually use size. I use size bytes as well. Get size bytes. Just because there's that ambiguity there, you know. Okay, so this is referencing 6590.imf32. And the actual light is called 6950.imf32. So it's the right file. It's not actually. So it's appearing there in the sprite sheet. But if I open the level that it's in, it's not there. Which means we need to figure out what's going on there. So it could be this, possibly. Use this template when given e.g. standard array works where you provide a size. Oh, you mean number of elements at compile time? I'm not sure what I use for that. Count again. So it must be no. This is what we want to load it in. So it could possibly be this. It did pick it to be I32, R32. Yeah, so that move didn't work. Maybe that's what it is. Program is subjective when solo. Yeah, I mean, I think it's one of the reasons why it's an art form in a way. It's one of the reasons I really like it. It's expressive, you know, you can express yourself like any true good art form. So we don't have a move constructor for a texture. That's what it is. Which is fine. So we just want to mem copy the view over, and then buffer equals standard move buffer other dot buffer pixels is equal to buffer dot get data. Where's pixels though? Is it in the view? Yeah, so that's just gonna get copied anyway. Okay. I also want to see what it does with texture format as well, because that might be a reason why it's not working. So I haven't tested that. Raw texture reader with ID given a texture format. We don't actually need to send in a texture format because the image has got everything we need. But I'll check it. Oops, loaded the wrong one there. Okay. Do need to check that. I forgot to do it then though. Just check this move anyway. So when this drops out of scope now, the buffer is empty. So we're calling release residency. Don't want to do that. Which means this has to BM mem set. We'll do it here. Other 0 size of texture view. I want to wipe it out so we don't actually release the texture from residency. That would be bad because that would mean we would evict the texture from the GPU, which would cause like a graphics stall maybe. Bit depth, channel count, R32, so that's correct. So format, this is all working on formats, which is much nicer than images. Well, the texture seems legit right there. So why aren't we seeing it? So we have our light. And we have our distance field. fine. Just not showing it. Dr. Elliot, hey, how's it going? Hope you're doing all right. Let's have a look, see if we can get this what this texture is. All right, how do I print screen on this? F11. Okay. Oh, it's up here, look. In the wrong place. That's weird. That's it. So it's rendering it in the wrong place. Let's just see if we can actually see it. There it is. It's in the wrong place. Weird. What's going on there then, eh? So x minus 2. So it should be, x is meant to be minus 10. It's not really. Oh, it is because the texture is absolutely massive. So it must be rendering it at the bottom corner of it. I put in the bottom corner. Oh, actually opened RenderDoc there. I want to open Pix. Let's have a look at actually the size of this, where this texture is actually getting rendered. Right. Oh, I didn't capture anything. Come on. Just look at the wireframe. Yeah, look, it's completely... So it is like minus 10-ish. It is completely the wrong place, though. I don't know why it's drawing it a bunch of times as well. It's drawing it 3 times. Oh, one of them's shadows as well. So we got the glow, the shadows, and the front glow. Okay, so that is to do with this position doesn't get changed. That's what it is. This is like the local position, the light position. So if we So how does the light position get calculated? So it's board sprite lighting layer. Position. It's going to be too long. So it must be in the light's not. Position is P, which is this. Oh, this is quite complicated. So it's the local offset minus the local bounce width height over 2 plus some kind of offset, which is this. It's actually a difficult calculation, that. And the source box is the brush box. So what it means is we need to remove this from the calculation and add it in when we load the lighting layer back up. It's going to take 2 minutes and then we'll look at how to do that. So how are the local offset and the local bounds calculated? Because we might be able to just not have them. It's the bounds.center. Light radius world. Okay. Image layer, local bounds. So we call generate there. Let's do this. Ooh, man. So what might make more sense, actually? Ooh. Is to just store this in the actual light file itself. Oh, we could make a separate light file. So we could have the IMF32. If we don't have any more, but we could have the IMF32 and we could have a light file. Because basically this value is wrong when we regenerate the light with a different size. Yeah, that might be what we have to do. So what we might do is put position in here. That's the first thing we can do. Which is this calculation here. So we'll put a breakpoint there just to remember where it is. So maybe we just actually store the position, the offset rather than the position. What do you use to convert a string into a number? A British number. Is there a from cars? What do I use? From chars. scanf ultimately. scanf underscore s. That's what I use. Can it also handle hexadecimal? I believe it can, yeah. So you want %x for your format string, I think. So I've got something called a hex32. And then we want the format for that. %x, that's what you want. And that will do. So your scanf %x, then your hexadecimal number. Your hexadecimal string. I think that's correct. Right now I just have a bunch of tokens and they're just using views with a type. Okay, yeah. So if you want to get it back into a proper type from a string. So if it's a string version of a hex number, then %x, I think. I'll look at editor.config. Somewhere, there we go. I'm using it there. So let's go default grid color. We'll follow this code through. Hopefully we can. So this is a hex32, which is just a U32, really. Let's just get this building. follow this just to check, eh? Okay, so that's currently 0. V is U32, really. So, oh, we can't do it. Hang on, I need to turn off my JMC file. That just stops me stepping into, you know, library code. Okay. So it makes a view, so that's what you've got. We've got a view and then a thing. And then it's using %x. Find first scalar %x. Going through the lines. There's quite a lot of lines. So it's the first. Oh, it's a shame there's a lot of lines. It's line number 16 that we want. There you go. So it's going to compare the lengths. It's going to compare them. Compare the key, I think. Oh. Okay, get out of here. From chars. So we're in Unicode. scanf underscore s. So the string is OX. Is colon space OX424242. And the format is %x. And it puts it in there. There we go. So if we look at hex 42424242. Yeah, %x you want. Alright, generate some lights. So I think to make things simple, what we're doing in the actual room file is just, this is the position we need to draw the light. Actually, we don't want to store that. We want to store the offset. So we want to actually store this as P. Okay, so before I change this, I'm just going to check in because I'm not sure this is going to work. We'll see. What we actually want to store is this. And then we could actually make this minus. And then when we draw the light, we need to actually so the layer itself needs basically a get position, get world position. Just copy this over. Oops. Where do we put that? In the sprite sheet editor. Did we? So we're going to return local offset plus local bounds width height over 2 plus offset. That gets the world position from a sprite sheet lighting layer. Does mean, yeah, good luck, Fu Manchu. Hope it's alright for you. And then it'll be home time after that. Maybe. All good, yeah. Okay. And then what we're going to do, we can catch all this wherever we're using position, is we're going to name this. It's interesting, this is snappable. Why is this snappable? Usually that means it's because we're dragging it around the world. Okay, well, we'll just see. I'm going to call this offset. At least we'll be able to see everywhere we're using it now. Offset. Yeah, I mean, it's not gonna be snappable if we're not moving it around. So it must be somehow. Sprite sheet lighting layer. I don't know if we have the actual sprite sheet lighting layer here. I don't think so. So this is where we actually want to generate the position of the light in the game. We don't have what sprite sheet it came from. So this is where it would benefit from actually having a light, like a light file where we can store this stuff. Because we could just load the light file here and find all the information we need, really. Okay. Alternatively, we've got to load up the actual sprite sheet it came from. Which would be here. We don't actually load it up and read it out the sprite sheet. Could maybe do that. I don't think we know which sprite sheet though. Okay, I think we go for the light. The light file thing. Which means the sprite sheet editor. So we'll do sprite sheet light. So we've got properties here. I wonder if we could we could just add these two to the properties. That might also work. So that goes in here. And we do props dot local bounds props dot local offset. Like that. I don't think we need to hash those. Well, we could. Could even do scale. Actually, as well. We just got those things. Okay, so let's just sort that out. Let's fix the compile errors because we've put a bunch of stuff inside the properties. So those three go away. And here. So this is properties, local bounds. Scale. So this is properties dot. Okay, so this is like also pretty complicated, unfortunately. So what is this? Deep bob panel. This is drawing the brush for the light. So really this kind of like it's maybe the properties, you know, that need to get the position. So let's just copy this over. Get world space. Get world position. Actually, need the offset. And make that plus. Okay, so it's the brush location plus the offset minus the offset in that situation. actually on the properties itself. So this equals light, properties, world position, that's effect 2, offset X, offset Y, minus brush location. In that situation, I think. Yeah, we'll go with that. This is light.properties.scale. And this is another one. So P that, and P is equal to source light, whoops, up in there, properties, world space position, offset, but actually this to what we're in here, putting the position in there, we really need to just store the offset there. So this is where we go back to this being an offset. So this is just offset. And this is basically that. It is. I wonder why. I just wonder why it's a snappable thing. That means we can like snap it to as we're dragging it around. We'll find out. We'll find out. So we have the light properties here. So this is light properties. Get world position. Light dot offset. Is that correct? Seems good. What is position here? So this is Quarton. General purpose engine, specific sort of game in mind. So the engine's very much kind of like quest-based, dialogue-based, 2D, little person running around in a world, talking to lots of people, doing quests for them. It's that kind of engine. So there's lots of like, and it can build cutscenes and dialogue trees, behavior trees, quests. So it's kind of like an RPG style engine, really. But think about, you know, you could do something like old school Fallout in it, or something like that if you wanted to. Lots of open-ended stuff. It's not general purpose, really. It's not built for platformers or anything like that, or roguelites. Roguelikes. Scripting system over the ways to extend it. as yet. Like you can't, it's not the type of engine like Unity or Godot where you write scripts and then expose them to the editor. It's not that type of engine really. So you do definitely need to be a coder to like design with the engine or whatever. Like you can expose things to the editor if you want to, but it's not as straightforward really as something like Unity is. So I didn't see any reason there why the offset had to be wherever it is. Had to be snappable. This could just be a Vec2, I believe. There is quite a lot of power in doing things with the node graphs. It's got like a node graph system in it where you can define behaviors and things with node graphs. So it's pretty like you can do a lot without coding, but it's not got full blown like, you know, C# scripting, and it probably won't ever have that. Because that'd be like too much work really. I'll show you if I can ever get it to compile. Yeah, it's a little more like Cody than a general purpose engine. But it's only really made for me to make games with, so it's okay. You couldn't, like with Unity, you could give it to a non-coder and they could make a game. Which is one of the reasons why it's so good. But to actually build all that out is a lot of work. And really unnecessary for me. Like if you want to extend the engine, you just write the code for it really, essentially. I'll show you a way of how it's extended anyway. That's how you make gameplay with it. So you've got... Oh, thank you. Cup of tea. That'd be awesome. Yeah, great, thanks. So say like a dialogue, for instance. This is one of the characters' dialogue trees. So each node can have conditions on them. And there we go. It's a bit broken actually. So anyway, this probably will end up being some kind of searchable drop-down box. And then what you do is you author these conditions in the engine, in the gameplay code. This is a condition that the player is a specific character. And then the engine evaluates it from left to right. Put that condition back. So it'll be like, has the quest started? And this is a quest ID, which is this little simple quest here. If it hasn't, you go to the next one, then you evaluate the conditions there. So you get kind of like, Jenny can say a lot of things depending on the game state, and you could just author and author and author these, and these are each individual dialogue trees. And then this dialogue operate, you can give it to operate anywhere in the world, or you can actually give it a room. So you could even have Jenny say different things depending on which room she's in, different dialogue files depending on which room she's in. Like a room in the game is like kind of like a level. And then condition dialogues can fire events, and then you author the events in the engine. So if you wanted like the dialogue to end with a shop opening, you could fire the shop event. But you just author these, you see, and these can get exposed to the editor. So that's how you expose things through. This is like a C# script kind of. So this is like spawn NPC, and then you want whatever NPC you want to spawn, whether it's a static or dynamic, and then the trigger that they spawn from. But the thing is, like this, the editor doesn't really know about it. The editor just kind of like renders what it's told, and you actually author all these events. So as you're building up gameplay, you just author more and more events to happen, and conditions as well. And then if you want to say like give Jenny something to do in the world, there's two things. There's patrols. So this is Jenny's patrol. She's got 2 patrols. So there's one with a nav mesh and one without a nav mesh. So if she's on the nav mesh, she follows this patrol. And then if she's off the nav mesh, she follows this patrols. And then if you want more complicated things to happen, like if you look at another NPC patrol, like Spidey. Spidey's like an enemy in the game, so they have a default patrol, but they have a behavior attached. And then you author these behaviors. Oops. So if you open the brain up, this is a behavior. This is a general behavior that you could attach to any NPC. And this is a test for combat. So this drives all the combat for the Spideyans. And then in terms of coding, you author these actions. So there's bits you can expose bits to the editor, but it's also a lot of code in there as well. So I have different type of actions, and you could just like add a new action node in, and then like connect it to the graph, so you could have more and more behavior in. And you could do things like have dialogue send characters on different patrols, which trigger different behaviors. So there's that's how you build up gameplay, doing all that stuff. But yeah, it's fun. It's it's code driven rather than editor driven. And I do the editor just for where code would be just way too complicated. Like building up these trees, you could code it all. Thank you very much. You could code it all, but it would be kind of a nightmare to keep in your head. Especially because you can have nodes that call other trees and nodes that send events and all sorts of things. So this is just better for the editor. Same with dialogue trees, But like a lot of like quest state. So like this is a quest, and then you give it a list index, and the list index is just a section of code. So you can have a lot of code state in the quest as well. So you don't have to do it all through the graph. You can do it through code as well, and they like link together and talk to each other and stuff like that. So there is loads of gameplay already prototyped. I'm only kind of I'm getting right at the end of the prototyping kind of pre-production stage. What I'm doing at the moment is just tidying up how the lighting is generated in the editor, because that was crashing, and I wrote this a couple of years ago, and it's not very good really. So I need to just go back and tighten it up essentially. Thanks, Quarton. Yeah, if you've got any questions about it, just let us know. No problem. But you know, like anything, because you've got these general purpose events and conditions, you can do anything. So we could write a condition which checks some, like, I don't know, write a condition which checks the time of day. And if the time of day is this, then you could write an event which changes like the weather to be raining. And you could write those two things, the condition and the event, and then they're exposed into the editor for anything. So you could actually trigger that event and condition on dialogue using a dialogue tree if you want, or with one of those actions on the behavior tree. So you could rig up gameplay like Jenny walks over, she uses the behavior tree to walk over to make a cup of tea, and when the kettle is boiled it starts raining outside. You know, you can build up stuff like that with it. Alright. So we might not need the light file if this works. So if we open up, well, I'll tell you what we'll do. We will get rid of all this again and open it up the actual room in the editor. There's nothing in it. And then we will make a new layer. Okay, so the brush is kind of wrong. That's going backwards. And the offset's wrong. Oh, that's cool. So that's kind of where it needs to be. So that is to do with drawing the brush. Here, I think. No, that's, where are we drawing the brush? It's in something called stamp. Stamp content. Well, it's not the stamp actually, it's ticking the board panel in the paint mode. Here it is. So this is kind of wrong. Let's try that. Right, there we go. So if we stamp it, oh, we need a layer. And we save that. So we're just saving the offset now. which is independent of the light, right? The position of the light in the world. So if we do like 20, or like if we do like 40, make a really big light. So it doesn't update there, but that's the next thing to do, is to get it to actually update there. But first we will just check that when we reload it, it takes the new light. Which it does. That's a massive light. See it? I don't know if you can see that on stream, but it's like all the way out here. That seems to work then. So, oh no, no, doesn't work. We haven't looked at it. That's the wrong one. That's the sprite sheet. Okay, no, it hasn't worked. So the offset is the same. How is the offset even generated? Source box. Oh, so it needs the brush box, which probably is the thing that changes. Yeah, so if the offset does need to change, oh man, that's so bad. Such a shame. So if I was to stamp a new one on, well, it is 1 minus 2. Oh, look. Oh, that's weird. Didn't change, maybe I didn't save it. Oh, now I've crashed. It's not going well. Ugh. Yeah, I think we just go with the light file. That's going to make it much easier. Like 40. And then we'll open this back up again. I don't think that is actually right. It's not saving the actual light radius anymore. All right, I want to go with the properties file instead. So delete that. Let's delete that. Let's start again. Yeah, I mean, we could, for instance, when we save the sprite sheet, just go through all of the levels and update them all as well. That might already be doing. That might already be the thing in the engine. Um, Not sure. So there it is in the game. So what I want is, if I change this to 20, I'm going to click generate light. So let's just check if there is. These need to kind of get updated, basically. Well, this position needs to get updated. It's in a different position now, you see. Now I've generated the light. So we could actually load it up and just reset all the positions. It's quite a lot of work for it to do. Definitely needs to be a local position. That's what we need to do. It's all very complicated, that's the only thing. Too complicated, really. So let's rooms. Prototypes. White debug.room. E put some floor down because I can't actually see the light properly. So this offset is also based on the size of the sprite sheet. Sprite position plus light position. So I wonder if this offset, I'll just save this. The offset is local to the sprite. This position is local to the sprite. Oops. Okay. man. Too confused now. I'll have a banana. Get some energy. So So 64, 128224. Right, that is a world, that's in world space. So I'm thinking, can we generate this? Can we generate this inside the sprite sheet? Editor. I think we probably can. So when we do generate lighting, right? Which is here. It's here, isn't it? So let's see if we can generate that here. Where was it? Here, this stuff here. So okay, so the source box is the world bounds. So let's just run this code. Mm. So this is the tile. So we don't actually pass in. This source box is actually the size of the tile. So if you go to sprite sheet, lighting, layers, we've got a layer index. It has one tile on it. How do I know that this tile is associated with this light? How do I know that? Lighting layers. So is it get focus sprite sheet tile? Get focused sprite sheet. Not the tile though. Okay, so when on the game board content, or on the sprite sheet edit, on the board panel, when I want to move the sprite sheet, it probably just removes all the tiles with it, doesn't it? So that is the tile. Don't know if we can actually make this thing. Oops. So like in the content browser, when I do this, so that's the tile. How does it know there's a light associated with it? Something to do with brush. Set tile brush, sprite sheet tile. Gets the collision buffer. And the JMC back on. So we set the tile. And then we set the tile. And then we stamp it. Sprite brush, source path. So the sprite sheet just has lighting layers in it. Yeah.
6 o'clock.
Yeah. See you later.
I've got 1 minute to
Yeah, no problem. See ya. So it just looks like it adds all the lights in for this tile. All the lights for the entire sprite sheet in. Kind of makes sense. So we maybe need to store the source box, perhaps. When we load it up, we got to work out the position. All right, let's put this Snap JMC thing back on. So I think we need to store the source box. So we'll start by doing that. Okay, so this doesn't actually need to be... well, we'll leave that. So it's underneath position. Where's source box? It's a rect U. So we'll do that. We'll start off by storing the source box. When we actually stamp it down. Okay, so that means get rid of all that. I'll run the game. So the idea is we remove this position and we leave it with things which are just based on the tile and not on the light. We'll leave position in for now. So that shouldn't change if we change the light. It only changes if we change the size of the tile. The source box. Let's just check. That there. We need to make a layer again. And we save that. And we have source box. There we go. Okay, so now let's try and regenerate this position. Using that source box. So we could probably store in this sprite sheet. Sprite sheet height is going to change, so we can't store that. So when we draw the light, game board content, draw, we do begin light, so it's here really. We have light dot source box now. So and we have the distance field height. We need the sprite sheet it came from, that height. If we're storing the source box, we could probably store the sprite sheet as well. Okay, let's just store, rather than the source box, store the offset. And then offset is just that. That shouldn't change. That just shouldn't change. Board sprite lighting layer. So it's the sprite sheet lighting layer, really. So it's these two. Right, so that's the actual layer local bounds. The light radius in the world. Yeah. Okay, we're gonna go for a light file. This is gonna be called distance field path, light file path. Light file path. Like this. Oops. distance field path, and then a light file path. Still here, yeah. I'm just kind of exploring how it's like when I build lights in the sprite sheet editor thing, and then I've got lights of the same type in the world. Some properties I want to transfer across the world. Some I don't, like the color and stuff, because you want to be able to set them individually on different lights. But the things like how big they are, that needs to come from the sprite sheet really, because that's a texture on disk. But the thing is, if I change the size of a light, it changes all of the positions of the light in all of the game. Where that instance of the light, you know what I mean? Because the light just like, the position is kind of like defined as like offsetted from the it's like the local to the thing that it's attached to, that's giving it like, well, you know, like the sprite it's attached to or whatever. So I'm just kind of working out how the minimal kind of changes I'll need to make, I suppose, to have that work. But yeah, hope your meeting was all right. I think what I'm going to do is I'm going to create another light file. So this is the distance field, and then the light. We're going to have a light file which is going to store some properties that I need to be able to calculate where the lights are in the world for each particular object. Yeah, I'm here till 5 today, so I've got another half an hour. All right. So this is the distance field path. So this is the distance field path, and this is the layer dot file path. And then we want things in the that are in the light file path to come up somewhere. So we're going to have struct light file. Secord C. Hey, how's it going? Welcome. If you got any questions, just ask, no problem. So we just need to store some stuff in here. I'm not sure what actually we want to store in here yet. We need to basically store how we generate everything we need for generating this position. So we need the source box, so that's a rect_u. And then we need the sprite sheet height. We need a bunch of things. We'll put those in. We'll just go with them for now. And then we want to just be able to save this somehow. So we just want to go L class box. Local bounds. Local offset. Like that. That means we can save this into a file. So wherever we where do we do this? Generate lighting. Here we go. So we're just going to go. So this is the distance field path. This is the light path. The light file path. I'm going to call that dot light or whatever. And then when we actually save the sprite sheet lighting layer, we need what's in the light file. So we need text writer, default layout writer, so we need a TW string builder there. And that's builder, and this is the light file. What is it? Layer.light file. Like that. And then we want to go builder file write layer light file path layer the builder begin. I think that's it. String view. I'll just pass in the builder like that. See if that builds. Okay. So we're going to delete the distance field path and the light file path. That's the distance field path. Okay. Had an internal compiler error there, which is never a good sign. Okay, so what that means is that this has to be begin. Okay, so now we just need to actually populate what's in the light file. So they can go away, right? So they actually are in the light file. And that goes. That goes. Where are we? So the hash. Do you probably want to do layer.light file? Don't actually know how to hash that. I think that's probably going to default. That's probably going to be fine. Okay. So this is light file. And then the source box is actually the bounds. It's in. Apparently, it's in screen space, but we'll store it in world space. That is in world space. So it is in world space. So right. So this has to basically go. Might actually pass the image layer. What is an image layer? It's a PSD layer. I think it's just the image bounds actually. It's input image get bounds. That's actually is going to be in screen space, which is good. Or in pixel space. Okay. So let's delete the light, and then let's empty light debug room again. Run the game. The light. So we do generate lighting. Got no IntelliSense, which is not great. It's not built it. Let's rebuild. Still not done with the review. 25 files to go. So it's going to be a full day's work then. It's actually taken. It's been quite a slog of a day for me actually. Obviously, nothing compared to you. But everything's been taking a lot longer than I thought it would. Second day. Oh no. Yeah, I mean this is quite old code and it's quite complicated. So it's just taking me ages to realise what's going on. To try and, you know, change it. It's all kind of like, you know, little calculations to do with boxes in tile sheets and stuff like that, you know. Why does it do that? Why does it delete what's ahead of the cursor? Don't use shared pointer because it's easy to forget about ownership. Oh yeah. I don't really use pointers at all most of the time. I try not to. Lots of references. But managed, apart from a few of the like low level engine things that need pointers, most of like the gameplay system stuff doesn't have pointers in it at all. Like the gameplay code. Like, I think maybe all of it, like exposed anyway. No, this is the distance field path. So this actually also needs a light path. Light file path. So this is how we're going to get the information that we need through this path. I'm not adverse to using pointers. It just hasn't happened, you know? Solving who owns what. Yeah. Yeah, I have kind of a clear memory ownership model in the gameplay, really. I suppose that's why I haven't needed to use pointers. So everything's kind of created in like static, in global scope, you know, rather than nude. But it's not really, it hasn't crept up, like pointers has not been a thing. Or like smart pointers or anything. Like all these arrows aren't actually pointers, like loads of them are optref. So I have a thing called optref, which is kind of a pointer. Well, it is a pointer really, but it's more of a reference. It's like standard optional of a reference. And an optref by design, because you know it's a reference, not a pointer, is weak. You don't own it. Still remember auto pointer? No, I don't know auto pointer really. It's a first stab at smart pointers. Oh right, okay. No, I don't know auto pointer. I have written a smart pointer system before, a reference counting thing, which was good, which was basically just the same as the smart pointers in deprecated a while ago. Yeah. I wrote like a pointer, smart pointer system. You know, when I was like understanding what they were, I think the way that my brain likes to work is we'll remake that. Same with like I was showing you this morning with the lambdas, the like shorthand lambdas. I'll just remake it. I'll spend a day, and I did some reference counting stuff, and then never used it ever again. My style of coding, I suppose, is not like a pointer thing. I don't really use many pointers. Like, obviously there's pointers happening, but it's all hidden away, you know. Okay. So if this works, we'll generate this light. We have our source box. So it isn't that. The input image is we need the global. We need like where it is in the PSD image. I'm not even sure actually that needs to be set there. We can just set it here. It's image layer dot pixel bounds. Must be that. Too dumb for smart pointers. think like if you're, I don't know, like certain styles of coding, especially if you're doing a lot of object oriented stuff, need pointers. Like for instance, if you wanted, like, if you had game events and they're all different, you got like 10 game events and they're all different types, and then you wanted to store a list, an array of game events, you can't do standard vector because they're all different types. So one of the ways you could do it is to have them all inherit from something like iGame event, create pointers, and then store a list of pointers, which is a very object-oriented way of doing things, which is a good way to do it as well. But what I tend to do is store all of the game events in a tuple, have them be created when the game starts in global scope, and they're in a tuple, so they're all next to each other in memory, and you can iterate over them. I'll do it that way instead, so there's no pointers, you know. Wow, crazy. Obviously you need to know what they are, obviously. That's crazy, that. And then in the future, like if you did want to store a sublist of previously created game events, I would create a type that does that rather than just store an array of pointers. I don't know, I don't tend to do it. I don't tend to use them. It's crazy that you hired a principal engineer that doesn't know about pointers though. That's mental. Right, we can get this, just see if we can get this light file made. Like, how would I store a sublist of game event pointers? Now I'll tell you what I do. I have a thing called game event, which is, it's got some I call it hybrid storage. So you've got hybrid storage, which loses the type of the actual game event. So you can store any game event object in the game event object. And I'd store an array of game events. That's probably what I would do. Like there is this thing, where is it? I definitely have a thing called game event. I think, maybe I don't. There we go. So this is a game event. So if I wanted to store an array of different types of game event, I'd probably just store an array of this. And this has some data in it, game event storage. So I could just pile in different types of game event into there. And it loses its type. So an alternative would be to actually create an iGame event and have all the game events in the whole game inherit off it. Uses void everywhere. Yeah, void's pretty dangerous though, because anything that receives a void pointer, apart from if it's in an allocate memory routine, doesn't know about how it's aligned or what actually even it is. It's technically undefined behavior, I think, isn't it? You're much better off creating your own type erasure system instead of using void pointer that's strongly typed, like standard any. All right. I'll do inheritance. Okay, so we'll generate lighting. And the light file source box is this, which seems wrong as well. Maybe it's right, I don't know. Wow, that's crazy. That is crazy, isn't it, that? Yeah, man, that's crazy, isn't it? When you just put random hard-coded values. There's one in Visual Studio, which is like, you're only allowed like 63 levels of... It's for a NatVis. I get this error of like, there's more than 63 elements in this thing. Therefore, I won't do it. It's not an array type. I can't remember what it is. It might be recursion levels or something. $1 gig to store the thing on 20 minutes. Wow, crazy. Players need to get better hardware. Players can't afford it, man. Okay, so there's the light. Do we have this light file? We didn't have the distance field file though, but we do have the light file, which is full of nothing, so that didn't really work. Gonna have to head off in a minute. Okay, that's in the wrong place. Start with. Yeah, especially for an SDK, blooming heck. The whole point, isn't it, is for it to get it out there everywhere. Right, I'm gonna have to head off. It's time for me to go. It was a slow stream for me. I didn't get much done today. I must be tired or something. But whatever. I'll keep going. I'll keep going with this over the weekend. Yeah, he was not happy. Yeah, I mean the thing is though, that's your job, isn't it? You've got to keep it. You've got to keep it straight. Yeah, it's the managerial part of the job. Yeah, take care. I'm not on tomorrow, unfortunately. I'm on next Tuesday. For the next couple of weeks, I'll be on Tuesdays and Thursdays. And then when we get into September, I'll be back full time. But yeah, see you in a bit.